Hello everyone, welcome back to my channel. In this video, we will try to derive the equations of motion in one dimension. Here, we are considering a situation of a uniformly accelerated body. Uniformly accelerated body means if the change of velocity with respect to time is a constant, then we can call it as a uniform acceleration. Now let me draw a graph which shows the uniform accelerated motion. For example, if we consider on the y-axis the velocity, on the x-axis time period. So this is the velocity on the y-axis, on the x-axis the time period. Now I am drawing a graph for an object which is moving in uniform acceleration. So this is a straight line, it is a linear graph because the rate of change of velocity with respect to time must be constant. Then only we can call it as a uniform acceleration. Now I am assuming that the initial velocity, an object is moving with an initial velocity of u meters per second. After a time t, it has attained a velocity of, so let me consider this as time t. After a time t, it has attained a velocity v. Now, I want to know what is the displacement covered. So, the displacement covered can be obtained. So, this is the displacement. So, displacement covered can be obtained by taking the integration of this VT graph. If we take the integration of this VT graph, we will obtain the displacement covered. How can I do the integration? So I am dividing this total region into two regions. Let me consider this region as a rectangular region. So this region is a rectangular region and this region is a triangular region. If we find the area of these two regions, we can easily find the displacement S. Now, for this rectangular region, we know that this length is t and this height is u. So, the area of this rectangular region is u times t, because for a rectangle, the area is length times breadth. If you consider this height of a triangle, this is the height. We know that the total height is a small v and this height is u. So this will be v minus u. Okay. Now let me find the displacement made by the particle. S is equal to, how can I find the area of first region and the area of second region? What is the area of first region? As it is a rectangular region, the area of first region is u times t. Similarly, the area of second region is half into base into height. For this triangle, the base is t. So, half into t into, what is the height of this triangle? V minus u. So, v minus u. Now, how can I find it? Ut plus half into t into, we know that the acceleration, let me write the acceleration value here. So acceleration is equal to the rate of change of velocity. So v minus u by t. If initial velocity is u and final velocity is v over a period of time t, the acceleration is given by a is equal to v minus u by t. Now v minus u, how can I write v minus u here? I can write v minus u as a times t. Now by substituting this equation, v minus u is equal to at, here you will get into at. So that you get one equation of motion in one dimension, which is u times s is equal to u times t plus half at square, half at square. So this is the equation 1, or this is one of the equation of motion. Next, let me find another equation of motion. How can I find it? Let me check. So in the same expression, we know that the average uh, displacement, or the displacement can also be written as by time is equal to velocity, or the average velocity is given by displacement by time taken. Now I can write s also as v plus u by 2 multiplied with t. From this equation, how can I write t? T is equal to v minus u by a. By substituting that equation here, you will get one more equation of motion, which is v plus u by t multiplied with v minus u by a. Now it is like a plus b into a minus b. So a plus b into a minus b is v square minus u square is by 2a is equal to s. Now how can I get the another equation of motion? So let me write here v square minus u square is equal to 2as. So this is the second equation of motion, we can understand. Okay. Next, what is the third equation of motion? From this equation itself, we can get v is equal to u plus at. So this is the third equation of motion. So finally, how many equations of motion we can get? Let me write clearly. First equation of motion. So the three equations of motions are v is equal to u plus a times t, means final velocity is equal to initial velocity plus acceleration over time. Second equation will be s is equal to u times t plus half at square. It is obtained by taking the integration or the area under the curve of vt graph. Similarly, next equation will be v square minus u square is equal to 2as. So these are the three major important equations of motion. In the next class, we will derive one more equation of motion which is useful in one dimension. Okay. So if you have any doubts in this video, please post them in the comment section so that I will try to clarify your doubts. If you really like this video, please share and subscribe to my channel, and also click on bell icon to get notifications whenever I uploaded a video. So thank you very much. Bye everyone.